Good evening to one and all. I am from the Institute of Aeronautical Engineering. I am going to explain about my concept video, that is electrode potential, and which is related to the chemistry. And my name is Alampalli Akil, and my roll number is 2095 2105. I am related to the aeronautical engineering branch. Electrode potential. Electrode potential means what? The tendency of a metal to go oxidize or reduce when it is placed in the solution of its own salt is called the electrode potential. When a metal M is placed in a solution containing its own ions M plus, then the metal may undergo either oxidation. The metal may undergo either oxidation and reduction. If metal undergoes oxidation, then the positive ion may passes in the solution M equals to M plus Na, which is oxidation reaction. If metal undergoes the reduction, the negative ions may deposit the metal M plus N electrons equals to M. This reduction. First of all, you have to know about the zinc. Zinc is a readiness of our solution. When zinc placed in the solution of its own salt, zinc undergoes oxidation with the releasing of electrons. The electrons liberated in this process accumulated over the surface of the metal. Hence, the metal is negatively charged. Now, the negatively charged metal attracts the positive ions. The positive ions from the solutions. Hence, the formation of the double layer takes place. Formation of the double layer takes place near the surface of the metal. Copper. When copper is placed in the solution of CuSO4, the copper ions in the solutions get deposited over the metal and hence the metal becomes the positively charged. The positively charged metal attracts and the negatively charged sulfates of ions in the solutions, and hence double charged layer Helmholtzian electrode double layer is formed near the metal. We have two: single electrode potential, standard electrode potential. It is measured by the tendency of an electrode to lose or gain electrons when it is in the contact of the solution of its own salt. And standard electrode potential. Standard electron potential, it is measure of a tendency of a metal electrode to lose or gain when it is in contact with a solution of its own salt of 1 molar concentration of at 25 degrees Celsius. I have the differences electrodes, primary reference electrode and secondary reference electrodes. The electrode is formed out of by coupling of the electrode with the primary reference electrode. The potential which is arbitrarily fixed as 0. The important primary reference electrode is used as standard hydrogen electrode. The electrode potential is found. The electrode potential is found out by the coupling of the electrode with primary reference electrode, and the potential of which is arbitrarily fixed as 0. The important primary reference electrode and the standard hydrogen electrode. Standard hydrogen electrode is generally called as CG. It consists of a platinum wire in inverted glass tube. Hydrogen gas is passed through a tube at 1 atmosphere at the platinum foils. It is attached at the end of the wire. The electrode is immersed in 1 m of H plus ions solution at 35 degrees Celsius. The electrode potential of SHE is 0 at all temperatures. The electrode is immersed in the electron ion solution at 35 degrees Celsius. The electrode potential of SH is 0 at all temperatures. Standard hydrogen electrode. It represents that as platinum H2 at 1 atmosphere by H plus of 1 molar. In case When the standard hydrogen electrode acts as an anode, the electrode reaction can be written as the reaction can be written as H2 plus H2 H plus 2 electrons. When the standard hydrogen electrode acts as a cathode, the electrode reaction can be written as 2H plus 2 electrons plus 2 H2. Based on the electrode potential obtained reference, electrode potential of obtained reference by the hydrogen electrochemical series is obtained. Secondary reference electrode, which are known as saturated element electrode. Needs of a secondary reference electrode. The use of SHE is different because it is difficult to maintain volume of H plus ions containing and the pressure of the gas at 1 atmosphere. Also, the electrode will be easily get poisoned in case of traces and impurities in the gas, and hence other reference electrodes are used. Examples: saturated calamine electrode, saturated of KCl. Saturated calamine electrode. It is commonly used reference electrode. It consists of a glass tube that consists of a Hg at the bottom covered with the solid Hg2Cl2 mercury chloride, and above this tube is filled with the KCl solution. The platinum wire is touched with the Hg and it is used for electrical contact. The KCl solution inside the tube and the ionic contact with the solutions outside and acts as a salt switch. The electrode potential of the garment is plus 0.2422 volts. As shown in the figure, below is known as HT and below the above is known as Hg2Cl2, and the solution which is in that contained beaker is KCl, potassium chloride. Determination of the standard hydrogen electrode potential of silver using the saturated calamine electrode. To determine the electrode potential of a silver electrode immersed in 1 m of a solution means 1 molarity of the solutions of AgCl silver chloride. The Ag half cell is connected with the calamine half cell through a salt bridge of the potassium chloride. Since the reduction potential of a coupled Ag electrode is more than the electrode potential of calamine electrode 0.222422. The calamine electrode behaves as an anode and the Ag acts as a cathode. We can observe that as figure shown, determination of standard electrode of potential. The cell may be represented as Hg, Hg2Cl2, KCl, double slash HgCl, 1m, Hg double slash represented as a salt switch. And left and right side represents as oxidation reduction. The EMF of an electrode, EMF of a cell is measured in the potentiometrically at 25 degrees Celsius. It is found to be 0.56 volts. E0 cell equals to E0 minus E0 R by E0 plus. E0 minus means right side, E0 L means left side. 0.56 found to be equals to ER have to find EL means 0.2422. And the final overall reaction we get that EG means right hand side reaction we get 0.8022 volts. Thank you for giving this opportunity.